This is a quick video tutorial on how to figure out when is the best time to observe an object if you have its celestial coordinates, its right ascension and declination. You need to figure out when is it highest in the sky, which is its transit time, when does it cross the meridian. Once it's on the meridian, its declination will tell you how high above your horizon is, and that depends on your latitude. So this is just a really quick tutorial on how to figure those things out. Let's say it's September 22nd, the fall equinox, and we want to observe the globular cluster M15. So I need its celestial coordinates. I need its right ascension and declination. There are lots of places to get that information. If I just go to Google and type in M15 coordinates, you can see here is Wikipedia, and Wikipedia sometimes has astronomical information about various objects. So here's right ascension 21 hours, 29 minutes, declination plus 12, 10 arc minutes. Another good source that astronomers know is called SIMBAD, SIMBAD. This is really useful for finding lots of detailed information, citations to papers, various measurements. If I go to basic search, I can type in M15. And here's the object. There's a lot of information here, but I just want this first line, the coordinates, right ascension and declination. This is the right ascension here, 21 hours, 29 minutes of time, 58.33 seconds of time. And then the declination here is 12 degrees, 10 arc minutes, 1.2 arc seconds, positive. So that's north of the celestial equator. All right, let's just, for sake of example, let's round this off to 21.5 hours, and let's round this off to plus 12 degrees declination. So when will that object be highest in the sky? Well, I need to know what my local star time is. That's not the same as local solar time, which is what a sundial would read, and it's not the same as Eastern Standard Time or Eastern Daylight Time. But it's useful to know that on the day of the fall equinox, local star time and local solar time are the same. So if it's 12 noon, if we go to the planetarium simulator here, if it's 12 noon when the sun is on the meridian, let's go forward in time just a little bit to see the sun on the meridian. So here's local time, and if I step forward a few minutes, by Eastern Daylight Time, local solar noon happens at about 12:44. There's the sun on the meridian. Now on the day of the fall equinox, the sun also has a right ascension of 12 hours. That's because by definition, 0 hours right ascension is defined to be where the sun is on the spring equinox. So if we were to go to the spring equinox, let's do that. Let's go back to March. And it's going to be around the it's between the 20th and the 21st, so there's March 21st. Here, the right ascension of the sun is 0 hours and a little bit. So that's for the spring equinox. So the sun actually moves around the celestial sphere, changing its right ascension and declination, and it appears to move to the east by 1 degree per day. Now, of course, really it's the Earth that's orbiting around the sun, so that our line of sight from the Earth to the sun actually sweeps through the celestial sphere once per year. But in terms of just trying to figure out what right ascension is overhead, on the day of the spring equinox, then at noon, 0 hours is going to be overhead. On the day of the fall equinox, at noon, 12 hours right ascension is going to be overhead. And actually, you can work all the way through the other months of the year from that. Actually, on the December solstice, it's going to be 18 hours it'll be overhead at noon. And then for the summer solstice, it'll be 6 hours that are overhead. And every month is 1/12, roughly 1/12 of a year, an orbit around the sun. So the sun's right ascension increases about 2 hours per month. For purposes of trying to figure out when our object is up, it's easy because we're observing close to the fall equinox. So we just need to know what is the right ascension. Well, that solar time is when the object is transiting. That's when the object is going to be high in the sky. So for M15, we figured out that this is 21 and a half, so that's 9 p.m., 9:30 p.m. local solar time. Now, that's not going to be exactly 9:30 Eastern Daylight Time because Eastern Daylight Time is an hour ahead and we're not in the middle of the time zone and various other complications, but that's going to be within an hour. So let's actually see here. Let's go to Stellarium and go to fall equinox when we're observing, and let's go to 21:30. Local time. So it's actually Eastern Daylight Time. And let's see what right ascension lines are up here now. And actually, if I go to the equatorial grid, I can turn on a grid of right ascension and declination lines so you can see what they look like around the sky. So here you can see this purple line is the celestial equator. There's +5 degrees, +10 degrees, and so forth. Our object is going to be at a declination of about +12, so somewhere in there. Now its right ascension is 21 and a half, so it's actually going to be halfway between 21 and 22. So it's going to be right about there. So our target is actually right about there. Now you see it's not quite on the meridian because of daylight savings time. We have to wait another hour for it to get to the meridian, but it's pretty close. And so if I just want to know when the object is in the sky, I can just look at its right ascension. That will tell me the time. Now, when it's actually transiting, I can actually also use its declination to figure out how high above the south horizon the object will be. From the south horizon to the celestial equator in the sky, that angle is going to be equal to 90 degrees minus your latitude. Now, the latitude of New Haven is 41.3, so this has to be 48.7 degrees from there to there. So there's 0 declination, -5, -10, and so forth. If I went all the way down to the south horizon, then that would be -48.7 degrees declination right there. And I can't see anything below because the Earth is in the way. So if I want to know how high is the object above the south horizon, I'll just add its declination to that 48.7, 90 degrees minus my latitude. So it's going to be 48.7 plus 12, right? So that's going to be like 60.7. So it's going to be up here. So it's quite high above the south horizon, so that means it's going to be quite easy to observe. It's not at 90 degrees, that would be at the zenith, but it's not going to be down here at 20 or 30 degrees, which would be very challenging to observe and not a good target from this latitude. In general, things that are with declinations above about -20 are reasonable candidates for our observatory in New Haven. There's actually a very nice animation that I found on the University of Nebraska website, and I posted this at Classes V2 for Astronomy 155. And this is a horizon and a little observer, and this is a flash animation. I can scroll around and see his perspective from different points. This is the North Celestial Pole, this is the South Celestial Pole, and that blue circle is his meridian. You can see it goes from north to overhead to due south for him. The white line is his celestial equator. And if we actually change his latitude, you'll see that where that is in the sky, where his celestial equator is in the sky, changes. If you go to the North Pole, the equator is on the horizon, and the North Celestial Pole is directly overhead. If you go to the equator, then the equator goes high overhead, celestial equator goes overhead, and the North and South Celestial Pole are on the North and South horizon respectively. Let's set this for New Haven, so 41.3. And then we could actually put in the right ascension and declination of our object here. So 21.5 for M15 and declination plus 12. All right, and there you can see where the object is. And now I could change sidereal time in order to see when it's rising and setting and when it's going to be highest in the sky. So if I run time forward here, just by dragging the bar to the right, you can see the whole sky is turning towards the west. Let's all face to the south with the little man. And so now if time's running forward, you see the sky is turning from east to west. There's the object rising, and you can see kind of how high it's getting above the horizon. And it's transiting right there. It's transiting right when the star time is equal to its right ascension. So that's the best time to observe.